All right, exponential functions. These are the one set of functions that actually have some sort of real world application to them. And here's basically the scenario. The main points that you have to learn, understand, and know is that y is always going to be like some sort of current value. Okay? As in the current value that is attached to a specific time. Okay, so those two things are going to be linked. X is always going to be time. Y is always going to be a current value at this time. Current value at this time. All right. So the rest of this stuff in here then. The rule is made up of these two things. If I have a value for A and a value for C, I have the rule. Okay? We'll talk a little bit more about that later. Essentially, the A value is what you start with. Okay? I'm starting with a specific value. Okay? And then C is some sort of rate and put arrows of increase or decrease. Okay? And that one's the most complicated part about this guy in total. So where will this come into play? Let's just talk about, if you can understand two different worlds of this, then you should be set. It works with populations too, but let's think about the two real basic ways you'll encounter this. So example one, okay, I'm going to say savings account. Okay. And so when I say savings account, what I mean is it's you putting a starting value in. So I'm going to write Y, A, C, X. And we're always going to label it like this. Whenever you start a question, you're always going to label it like this. You're just going to have to be able to read, and Annie, you were talking about this, you're going to have to be able to read and decode from the paragraph, you know, which one's A, which one's C, which one's X. Now, to add on to this a little bit, I will point out, you can kind of add this above A, the A value, just right there, is going to be pretty. And the Y value is usually going to be ugly. So if you're reading through it and you're kind of unsure, and there's two values of money, and one of them's 50,000, and the other one's 67,298 and 76 cents, then that one is the Y. The ugly one is the Y. The 50,000 is going to be the A. Okay, does that make sense? We'll see it in a sec. So savings account. Okay, so let's just say we start with $500. So I took $500, put it into a savings account. Okay. Now here's the only part about it that's weird. Okay. A savings account, let's just say, has a 5% year-on-year growth, or even 4%. Let's just say. So 4%. You guys remember in grade 7, you can't directly take a 4% and just use it in math straight up. So there's got to be a little bit of work with this. The way I'll explain this is going to be when you go to look at something, no, Bradley, when you go to buy something, right? And you see that there is a price of a new, actually, Bradley, what were you just talking about? Some sort of GT something or other?
GT.
What is that?
GTA 6 trailer.
Okay, so if you wanted to go buy that and you go into the store and it says like $12,000, whatever it is, right? Is that all you have to pay?
No.
What else do you have to pay? Tax. Now, if you're calculating tax on your calculator on your phone, and the tax in Quebec, let's just round it up, is 15%, right? How would you use your calculator to identify what the actual price is that's going on your credit card, Danny?
If it's 4%, you do 100 subtract.
Oh no, but let's just talk about like buying an item. Like, so if it's 15%.
So we do 100 subtract 15.
Well, if I'm adding to it, right? It's going to be more than the $12,000. This
100 plus 15.
100 plus 15.
Divide that by 100. You know what I do to find 1,000?
No. Yours is 100, and then 100 plus 15, and then divided by 100 again. Basically, all you've got to do is think about it as.
So it's 0.115.
Right. Like if I had that 12,000, I'll just write up here. 12,000 in my calculator. I'm just going to multiply it by 1.15. Why? The 1 retains the original amount. And then the 15 as a decimal after is kind of like added on to the 12%. If I just did 12,000 times 0.15, I could figure out the tax, but that's not the same thing as the total. Does that make sense? Right? 0.15 is just going to give me the tax. 1.15 is going to give me a total. So for these guys here, you've got to think along the same lines. And 4% is a little bit tougher. So I'm always going to say 100 plus 4 is 104. And then just move the decimal place twice so I get 1.04. Right? That's now going to be the value I can use. So I started with 4%, knew that it was a savings account, meaning my money is growing. So the original 100% plus the 4%, let's just say every year, every month. Now, on something that looks like this, if they said for 10 years down the road, what is the current value going to be? I basically now just take the original, the 1.04, and the 10, and then we just plug it in. 1.04 to the power of 10. In terms of calculation, you do the 1.04 first, 1.04 to the power of 10. Now, you don't have to fully write this out in full. In fact, I'd probably just calculate it in its entirety, so you don't have to write out a crazy amount of decimals. But for right now, I want you to prove to me that you can find the button on your calculator that is going to give you 1.04 to the power of 10 turns into 1.48244.285. If you can't find it, everyone's calculator is different. Okay? My buttons, so I'm just going to write down here. So for those, my calculator buttons, right, are x to the power of 0. I've seen others that are x to the power of y. I've seen y to the power of x. What else do you guys have? Do you guys have anything different than that for exponents?
Mine's an upside down V.
Yeah. Oh, yeah. So then there's that guy too that will actually work as well. Okay. Make sure you can do that first before we move on.
I might buy a Texas Instruments 83 calculator.
Can't use it on the exam.
Why not?
What is it? It's a graphic calculator, so it doesn't work for you. So you can't have it.
Oh, okay. I'll buy that.
Just get these scientific
It
ones.
does
Fine.
the graph.
Yeah, it does everything. Yeah. Anyway, is anyone not able to do this, guy? Does everyone have a calculator in front of them that they're using and they can actually pull this off? Yeah. You sending you one? You got one?
You said you wanted us.
So prove to me that you can do this, and again, I don't want to move on until you can't get the 1.48. Yeah, I'll get to that guy in a second. I'm just recording. So everyone's good at getting 1.04 to the power 10 is 1.48. Okay. So then now I just multiply that by the 500. So essentially you calculate like going this way. Y is equal to $740.12. Now, I am always going to write out dollars and cents when it comes to money. And then in population, I'm always going to round it down. We'll talk about that a little bit later. So any questions on savings account, what just happened, finding of the C, all that stuff?
Well, I have more of a question on the process. Like, you don't want us to you want us to just
I honestly, if you just write this out in full, so you can, I know that you know where things went. You've identified the A, the C, the X, and then you just skip right down to Y is equal to 740.12. Then I'm happy.
That would be good on an exam.
That's fine. Yeah. Right. Like really and truly, like what's going to happen? Like if you skip down to the next row and you calculate it wrong, like that's one where I don't really need you to kind of really show the work. I know the calculation's wrong. There's literally only 2 steps to it. So and it's just easier. The reason why I say don't write this thing out in full is on my calculator, I would go 1.04 to the power of 10, take that answer and just multiply it by 500. I'm not going to go rewrite this decimal out again because I might make a mistake. So what are the other scenarios? And the most common one that actually is provided. It's either, actually, these are both like 50-50 what you'll likely see. So example 2 is going to be car depreciation. There's the key word of the day. Okay, and you can even next to this one, example 1, draw an arrow that goes up. You can put the word increase over this guy. Put an arrow down over here, you can put the word decrease. That's the only thing that's different with exponential functions. Sometimes we use it to figure out how much money I'm going to make down the road. Other times I'm trying to figure out how much money is my car going to be worth when I go to sell it. Okay? So we're going to use the same example that we talked about the other day, guys, with Tubman's truck. Was it $110,000?
Yeah.
Okay, so we're going to write down Y, A, C, X. Now, if you don't know this, the word depreciate means loses value. You've probably all heard your parents say, you know, the minute you drive the car off the lot, you just lost a couple grand on like your purchase, right? Like as soon as it's driven off the lot, it's worth less. It depreciated in value, is what they're saying. So Tubman goes out and buys a $110,000 Duramax diesel or whatever she has, yeah. And she's like, I want to keep it for 10 years. And I kind of want to have an idea how much it's going to be worth at the time that I sell it. Okay? So this is part of what we call adulting and budgeting. No? Okay. So a vehicle usually depreciates by 6 or 7% per year. So I'm just going to put down 6%. Let's be nice. And then we are also going to look at 10 years from now. Okay? So here's the scenario. The 6% now is what I'm losing per year. But I'm not necessarily concerned in terms of how much she's losing per year. The question I'm being asked is going to be, what's the value of the car 10 years down the road? So this 6% is now, let's take 100 minus 6, 94 is what I'd be left with, and then move the decimal 2 places so I get 0.94. 0.94. So now I have a starting value, I have a rate of decrease, and I have time to go ahead and plug in. And the one I'm looking for right here is going to be the Y value. Okay? Mm-hmm.
You put the same question twice.
Yeah, I know. Just skip it. Yeah. So now I just go calculate this guy. $110,000, 0.94 to the power of 10. So again, what this is saying is that her vehicle retains 94% of its value every year. And then I go 0.94 to the power of 10, and then multiply that by 110,000. And I get something like 59,247 and 66 cents. Okay? These are essentially the two scenarios that you are going to encounter in these guys. If this makes sense already, like the next week or so is just going to fly by. Okay? This is the only hard part, right? So I'm going to reiterate it again. 4% as an increasing question is essentially 100% plus the 4%, and then I turn that into a decimal so I can actually use it for calculations. That's the main purpose behind that. But for anything where it's decreasing, the 6% gets subtracted from 100. That means 94% of the value is what it's keeping, and I'll turn that into a decimal and go ahead and plug that guy in. The only added thing that I would have you guys write down on this front page is rate, or C, must always match time, or X. So the last example I would put on here in terms of your calculations, if it said something like savings increases 6% per month, which would be wild, but whatever. Okay. What value would it be 4 years later? So they mention in this guy. In fact, I'll even just go further and write. Actually, let's just stick to there. They mention in this guy that my increase is 6%. So C, shorthand, I know is going to be 1.06. Okay. I'll do this in a different color so it sticks out more. C is going to be 1.06. We're not going to do the full question here. What is X going to be in this case? If C must always match, or time, rate C must always match time. And like essentially the way it works is C is the one that matters the most. Okay. So X in this case is going to be 48. You don't go the other way around, right? It's if it says per month, then time has to be in months. If it says per year, time has to be in years.
48 months and 4 years.
So there's 48 months and 4 years. That's how I turned this guy into that. Those three things are literally this entire unit. The only thing we have to do now is use algebra to figure out, what if I was given a current value and needed to figure out starting value. Okay, but we'll get into that a little bit later. But that's exponential functions in a nutshell. I'll have you guys go down and skip right down to you see this page right here, the train station with rats. Now, I'll do this guy really quick with you and then let you try the rest. These questions can also be population. In fact, your C1 will definitely have an exponential population question on it. So number of rats in a train station doubles every week. So Y, A, C, X. So rats doubles every week. That makes it easy. Doubles means 200%. So I can literally just write 2. Doubles just means 2. Triple would mean I would write 3. Okay. If there were 8 rats at the start, well, they just said the magic word there, start. How many rats will there be 5 weeks later? Now, I have to go back and double check. It said doubles every week, and then it mentioned 5 weeks, so I don't have to do any matchy nonsense, right? It's just going to be 8, 2 to the power of 5, and I should remember what this is. 256, okay? So that's all it is. If this is making some sort of sense, then you're laughing. But that's exponential functions in a nutshell.